Hello, my name is David Webb and I'm a developer at Orb Data working on the Self-Service Portal product. The Orb Data Self-Service Portal enables global standards, change management and delegation across a systems management environment. In this video, I'm going to show you how Open Services for Lifecycle Collaboration, or OSLC, allows the Self-Service Portal to easily integrate with other management applications. Systems management environments usually consist of a number of different products, often from a number of different vendors. Integrating all these products so they can share information quickly and easily is a common but hard to solve problem. OSLC removes this problem by providing a common point of integration for all the products to use. An OSLC registry, such as JAS for Service Management, can be installed in the environment, and the different products either register the information they provide with OSLC or consume information provided by the other products. So, let's see how this works in practice. This is Smart Cloud Control Desk. We're looking at a computer system for which a problem has been reported about space in the /boot partition. As well as all the information available in Smart Cloud Control Desk itself, we can click this Federated Details button and see what other sources of information are available. This pop-up shows us the products that are registered with OSLC and are presenting information about this system that we're looking at. So, I select the item for SSP, and what we see is a preview straight from SSP itself. Each OSLC provider offers previews that are sent out as HTML, which means the consuming product, in this case Smart Cloud Control Desk, doesn't need to worry about the format of the data. It can just display the preview as it is given. This makes the integration both easy to implement and robust when other products change. So, this view I have up now is showing us live information from SSP. I can see what group this system is in and when the last change to its configuration was made. I can also click on this View in Orb Data SSP link, and this will launch SSP with this system already selected. So, this view in SSP gives us a lot more information about the same system. If I select the OSLC Previews tab, I will see a similar list to that which we just looked at in Smart Cloud Control Desk. SSP is an OSLC consumer as well as an OSLC provider. So this means, as well as supplying previews to other applications, SSP allows its users to view the previews presented by other tools. For example, I can view the preview from Tadam that shows a lot of discovered information about the system. In this case, I'm going to look at the Storage tab to find out information about the /boot partition. I can also look at the Tadam History provider and see if any changes have been made to this system recently, such as new disks being added, but there are none. As said earlier, whilst JAS for Service Management is an IBM product, OSLC is an open standard and so is not restricted to IBM products. For example, here's a provider from Icaro which shows information from the BMC Atrium product. This would be useful, for example, if we wanted to contact the owner of the system. Here is the preview from ITM that shows live data from the agent running on the system. We can see the current load on the system and information about disk usage. So we can see that currently the /boot partition is not full. OSLC providers do not just have to present UI previews where the provider renders the data. They can also provide the information in RDF format, which allows the consumers to parse the information and present it how they want. In this view, SSP is presenting the information from ITM as a series of charts, which here make it even clearer that /boot is not full. So, thanks to OSLC, without leaving SSP, we've been able to investigate the problem using live data from a number of other products. SSP also provides its own means of troubleshooting. This tab shows the tools that are available for this system. A tool in SSP is a command or script which can be run remotely on the system directly from within the SSP web interface. The tool definitions are defined by administrators, which means the end users are able to run the commands they need without needing full command line access. Additionally, all tool usage is audited, so it's easy to see who has done what and when. Here, I'm going to use the check disk tool to run the df command remotely on this system. The commands and scripts are run either via SSH or using the ITM agent, which allows SSP to make the tools available on all systems without the need for any additional infrastructure. Here we can see the output of the df command, and again /boot looks fine. So, if /boot is fine, the problem may be with our monitoring configuration. Configuration in SSP is managed through standards and profiles. Standards define global settings which are then used by profiles for specific groups of systems. The profiles can override the values from the standards as required. This view shows the system has one profile available, and that profile is currently applied and is up to date. So the next step is to look at the details of the profile itself. This view shows us the details of the configuration profile. We can see the ITM situations that are included and also from which standard these settings have been inherited. SSP also highlights where the situation formula has been overridden and so where the profile deviates from the standard. And we can also see where new situations have been added to the profile that were not included in the standard. When investigating this issue, we can also go a step further and look at the history of this profile. We can see all the previous versions of the profile and when these changes came into effect. Additionally, SSP highlights the changes between the versions. The blue colour highlights differences, so I can immediately see the newest version of this profile was upgraded to use a new version of the ITM Linux OS standard. Next, I can see the change brought about by this change of standard. The threshold for disk usage was changed to 90%. This tooltip shows the before and after values, who made the change and when it was made. This change does seem related to our problem, but I don't think it's the cause of it. What is more significant is this green line, which shows that this item was added in the most recent version of the profile. This has added an overridden situation which alerts to when disk space on a partition available is less than 1000 megabytes, and so is the cause of the alerts we are seeing about /boot. So, we have quickly identified the configuration change that has caused these alerts, and we can also see who made it. The final step then is to solve the problem and stop these erroneous alerts occurring. As SSP has a full version history for the configuration, it is straightforward to roll back to the previous version. This allows us to go back to a known good version and to do so for all relevant systems, rather than having to make an ad hoc change for a particular server. This, in turn, keeps our monitoring configuration under control and ensures that monitoring thresholds remain standardized in our environment. I hope this has been a good introduction to just how useful OSLC integrations can be. If you'd like to learn more about OSLC integrations that are enabled via JAS for Service Management, go to www.ibm.com/developerworks/servicemanagement/JASSM. If you'd like to know more about Orb Data Self-Service Portal, go to www.orb-data.com.